Welcome to this video on line following robot simulation. In this simulation, we'll be demonstrating how a line following robot operates. The robot is equipped with sensors that detect the red line on the ground, allowing it to follow a path. The simulation will show the robot following a track with twists and turns, and how it adjusts its movements based on the line it detects. As you can see, the robot is following the line with precision, adjusting its speed and direction as necessary. The simulation provides a useful tool for testing and refining the design of a line-following robot before building the physical robot. It can also be used to train machine learning models for autonomous navigation. Let's take a closer look at how the robot is programmed to follow the line. The robot uses a proportional integral derivative (PID) controller to adjust its movements based on the line sensor readings. This controller calculates an error value based on the difference between the position of the line sensor and the center of the line. The robot then adjusts its movements in proportion to the error value, allowing it to follow the line with precision. As the line twists and turns, the robot adjusts its movements accordingly, ensuring that it stays on track. Overall, line-following robots are an important application of robotics, with many practical uses in industries such as manufacturing and logistics. The robot would move along a predetermined path, while avoiding obstacles or adjusting its movements to account for changes in the environment. The video might show the robot using cameras or LiDAR to detect its surroundings, while the algorithms process the sensor data to generate control commands. The robot would likely move smoothly and consistently along the path, demonstrating its ability to follow instructions and navigate its environment with precision. The sensors could include cameras, LiDAR, or other types of sensors depending on the environment and the specific robot being used. As the robot moves along the path, the sensors would continuously collect data about its surroundings, such as the position of the path, the distance to obstacles, and the angle of the robot's movement. This data would be processed by algorithms running on the robot's onboard computer to generate control commands for the robot's motors or actuators. The videos show how the robot's behavior can be adjusted by changing its programming or adjusting various parameters in VREP. For example, the robot's speed or turning radius could be modified to improve its performance on the path. Overall, the video demonstrates how VREP can be used to simulate and test a robot's ability to follow a path, using a combination of sensors, algorithms, and control systems. The simulation environment allows for easy experimentation and iteration, allowing developers to fine-tune their robot's behavior and performance. Thank you for watching this video on line-following robot simulation. We hope you found it informative and helpful.